Use the derivative formula f prime of a equals the limit as x goes to a of f of x minus f of a divided by x minus a. To find the derivative of f of x equals 1 over the square root of 1 minus x, where a equals to negative 3, the first thing to do is to write the derivative formula with an a value of negative 3. So that'll be f prime of negative 3 equals the limit as x goes to the negative 3 of f of x minus f of negative 3 over x minus a negative 3. The next thing to do is to place f of x in 1 over the square root of 1 minus x. Subtract f of negative 3, which means f of x with a negative 3 plugged in for every x. So 1 over the square root of 1 minus a negative 3. And then all this over x minus a negative 3, which is the same thing as x plus 3. We have the 0 over 0 indeterminate form here, and we will continue to have that until we can factor the numerator to give us an x plus 3 factor that will cancel with the x plus 3 factor in the denominator. We don't have the ability to factor the numerator right now. What we do have in the numerator are two fractions that are subtracting. So we're going to have to get a common denominator between them. We'll want to simplify that second fraction first before we attempt the common denominator. It will just be a number of some sort. Since the fractions, one of them at least has a root in it, after getting a common denominator, we're going to have a root combination happen, which means we'll probably also have a root conjugate as part of this problem. So we'll just take this step by step. Let's simplify that second fraction so that we can get the common denominator. So we have limit as x goes to negative 3 of 1 over the square root of 1 minus x minus 1 over the square root of 1 minus a negative 3 is 1 plus 3, and that's going to be a 4. So we have the square root of 4 over x plus 3. That just looks nicer. And as a matter of fact, we can take the square root of 4 and make it even a little bit nicer. So it'll be 1 over 2. Our next step is to get the common denominator. So I need to multiply the first by, well, looks like we have a denominator of root of 1 minus x and a denominator of 2. The common denominator would be the 2 multiplying each other, 2 times the root of 1 minus x. I have to multiply this first one by 2 over 2. And I have to multiply the second one by a root of 1 minus x over a root of 1 minus x. And all of this is divided by x plus 3. So we have the limit as x goes to negative 3 of that first one multiplying the numerator. 1 times 2 will give us a 2. The second one multiplying the numerator, we have a 1 times a square root of 1 minus x. And it's being subtracted, so minus the square root of 1 minus x. They will now be over the common denominator, which is the denominators multiplying each other, which is just 2 times the root of 1 minus x. And all of this is divided by x plus 3. The next thing to do is to take the denominator, which is x plus 3, as a fraction. Let's put it over to 1 to make it a fraction, reciprocate and multiply it. So we have limit as x goes to negative 3 of 2 minus the square root of 1 minus x over 2 times the square root of 1 minus x. And then times this by 1 over x plus 3. Multiplying the numerators, we will have 2 minus the square root of 1 minus x. Multiplying the denominators, we'll have 2 times the square root of 1 minus x times an x plus 3. I'll put the x plus 3 in between. Everything's multiplying, so the order doesn't really matter. Just maybe look a little nicer to have the root on the end. I know there's some temptation to cancel this root here with this root here. The reason you can't do that is the root in the numerator is subtracting with another term. It's not multiplying. It has to be fully multiplying. The one in the denominator is fully multiplying everything, but the one in the numerator is not, so we can't cancel those. We still have the 0 over 0 indeterminate form. We haven't changed that just yet, but we've put it one step closer to be able to factor the numerator to get an x plus 3 factor. What we do have in the numerator now is a root combination. A root involving the variable x in some way, added or subtracted together with at least one other term. We're going to need to multiply the numerator and denominator by the root conjugate. The root conjugate is the same root combination but opposite sign between the terms, so it'll be 2 plus the root of 1 minus x. We'll put it over itself so that when we multiply the 2, we are multiplying by a form of 1. We don't change the value, just the look. Limit as x goes to negative 3 of. Now, the numerator is a root conjugate pair. We're going to FOIL it. First, 2 times 2. That's a 4. Outside, 2 times the root will be a positive 2 times the root. Inside, negative root times a 2 will be negative 2 times the root. And last will be negative root of 1 minus x times a positive root of 1 minus x, which will be a negative 1 minus x, but notice that it's negative of the entire 1 minus x expression. Put it in parentheses so we'd be sure to distribute that negative sign. The outside and inside terms of a FOIL of a root conjugate will always cancel. They're equal value and opposite signs, so let's cancel those out. In the denominator, we're going to have a 2 times an x plus 3 times the root of 1 minus x times a 2 plus the root of 1 minus x. We're not going to distribute or FOIL that because that is not a root conjugate pair. Just keep them all multiplying each other. Now, in the numerator, we have a negative sign that we can distribute here. Let's do that. And that will give us limit as x goes to negative 3 of 4 minus 1 plus x over this denominator. Just be sure to write the denominator exactly as you see it. Watch every term. We have like terms in the numerator that can combine. 4 minus 1 is going to be a 3. And so we'll have limit as x goes to a negative 3 of what will be a 3 plus x. And that's going to be over 2 times x plus 3 times the root of 1 minus x times 2 plus the root of 1 minus x. The 3 plus x in the numerator is making the 0 in the numerator. There's an x plus 3 in the denominator that's making a 0, and those can now cancel, leaving a 1 in the numerator. And we now have removed the 0 over 0 indeterminate form. I'm just going to write what we have. Limit as x goes to negative 3 of 1 over 2 times the square root of 1 minus x times 2 plus the square root of 1 minus x. And we can plug a negative 3 in for the remaining x's since we no longer have the 0 over 0 indeterminate form. That will give us 1 over 2 times the square root of 1 minus a negative 3, and then 2 plus the square root of 1 minus a negative 3. This is going to be 1 over 2 times the square root, 1 minus a negative 3, 1 plus 3 is a 4. So this will be square root of 4. And then this will be 2 plus the square root of 4. So we have a 2. The square root of 4 is a 2. And then we have 2 plus a 2. 2 times 2 is a 4. 2 plus 2 is a 4. We get 1 over 4 times 4, or 1 over 16. That represents f prime of negative 3, which is the derivative of the f of x with a negative 3 plugged in for all of the x's.